Okay, so what we have here is a little toy lathe. It's a 9-inch diameter part by 14 inches long. The first thing you do when you start up a lathe for the first time, and this one was started for the first time this morning, is you make sure that the tool's cutting on center. So Jeremy, would you start her up? And he's just going to bring the tool in and cut the end of the part. You can see the part spinning. That's really the key to it being a lathe. He's going to come in slow because he doesn't want anything to crash while he's watching a video. So all he's doing is he's going to cut to the middle, and if the tool's cutting on center, it'll cut the part off all the way flat. The tool's never exactly on center, so it's going to leave a little bit of a nub. And when it does, the size of the nub, the radius of the nub is how far off center you are. So you see he's cutting across the face. You just got to crank this, running the tool across. Okay. So what you got's what you got. You stop it. So you can see there's a nub in there. There's probably 50 thousandths in diameter, so we're off by 25 thou. If you look on the other side at the high quality shims that we use to do the job, they're nothing more than 1/2 inch washers. We really didn't have a chance to get within 10 or 15 thousandths of size. Now it's critical when you're running a lathe that the tool be on center or slightly below. If it's on center, you're at optimal, you have the minimum horsepower you're going to use. If you're high, the problem is that the part rubs on the back side of the tool. And it gives you so much thrust that it becomes really, really hard to push the tool forward. So you want to spin the tool post and make an OD cut now, Jeremy?
This way?
Yeah. Unscrew it. Yeah, even a little bit more just so you get a corner of making the cut. There's something wrong there. Okay. So if you look at what he did, he just rotated the tool so that the corner of the tool is going to be cutting on the outside diameter. And this is a classic case when you're using a little lathe. The thing he's going to be most careful of as he makes the cut is that the chuck doesn't hit anything he doesn't want it to. So when we're looking at the chuck at this point, it's real easy to see where it's sticking out and what it's doing. But once it starts spinning, it's going to look about like it does in your video. So go ahead.
I think you pull it out, right?
No, you got to spin it in the direction the arrow says. There you go. So again, he's got two handles there. The one on the left is, or the right as you look at it, makes the tool move in and out, move the length of the part. The one on the left as you're looking at it is the one that makes the tool adjust in to make different size cuts. Okay. He moves back out, and if he wants to take another cut, he just adjusts in with. See how he gets that continuous chip as long as he feeds fast enough. So feed a little harder for me. Give me a good long chip. See the long twisty chip coming off. In automatic machines are running at high speeds, that's an issue because you got to get rid of the chips to keep them from getting caught in the cut. Very good. Why don't you put a chamfer on the end of the part now? So do it by spinning the tool to go the other way. Use the end of the tool. Yeah. You can see he's just rotating the direction that the tool is on the mold, so that it gives them a something like a 45-degree angle. This time he's feeding on the in towards the diameter, and the reason he's doing that is that that knob moves the tool less distance per rotation. You see he's cut a chamfer there. That's good.